to everyone. Now we are going to see about the thermochemical conversion by combustion in the unit of in the subject of biochemical and thermochemical conversion of biomass. Last unit we see about the what are the biochemical conversion. Next in this unit we see about the thermochemical conversion of biomass. How the biomass are converted into the biofuels. Biofuels are syngas producer gas by thermochemical conversion. Thermochemical conversion means we heating the biomass or adding the heat to the biomass, then the biomass, how the biomass are converted into the fuel. Next is the biomass having a beyond 70% of moisture means it is a when the biomass or moisture content is very high. We preferred the biomass to send to the conversion of biochemical conversion. We use a biochemical conversion because of the moisture content is very high. By removing this amount of moisture content is very difficult in the thermochemical conversion. So we preferred this kind of biomass, and the biomass having a greater than 70% of moisture content. We decide it is preferable for a use biochemical conversion. And the biomass moisture is less than 30%, we choose the thermochemical bioconversion. This is the energy conversion chart. This is the energy conversion chart for the thermochemical conversion. This is a stoichiometric ratio and elemental composition. Elemental composition means carbon plus oxygen converted into the carbon dioxide. This is a reaction. A carbon added react with the oxygen and forms a carbon dioxide. Nitrogen reacts with the oxygen forms a water vapor. And methane forms with the oxygen and forms a carbon dioxide and water vapor. These are all the reactions takes place in the combustion. Stoichiometric ratio means next is stoichiometric ratio. What is mean by stoichiometric ratio? It is how much amount of air required for a complete combustion of a fuel. It is a stoichiometric ratio. Suppose we use a methane as a fuel, means the stoichiometric ratio is a 7.2 kg. Means for complete combustion of a 1 kg of methane, we require 17.2 kg of air. Same case as a kerosene. For a kerosene, 1 kg of kerosene fuel, we require 14.6 kg of air for complete combustion of a kerosene fuel. Next is the principle of combustion. This is a chart for what are the density, how much ash formed when combustion of this kind of biomass. In combusting of this kind of biomass, how much amount of ash formed. Based on that, lower the ash formed means higher the heating value. It is heat of formation. Next we calculate we see the values of a lower calorific value or higher calorific value. The calorific value is how much amount of heat we can obtain by combustion the biomass. It is a calorific value. By seeing the calorific value of the biomass, we can choose the different types of biomass based on our applications. Applications are biomass availability. It's a gas composition at high temperature and burn rate of solid fuels. It is a combustion systems. Large combustion system, what are the components in the large combustion system? First one is a traveling grade, stalker type, inclined grade, vibrating grade, bubbling fluid bed and a circulating fluid bed system. Traveling grade means it is a solid component or solid grill type structure. Over that biomass are placed. In that place combustions takes place. That is a traveling grade. Bubbling bed means the fuels are made as a powder particles. It is floating on the air. And start combustion in floating itself. After combustion, it travels to the exit from the combustion chamber. It is a diagram for a large combustion chamber. By seeing the right side diagram, below the end stalkers are overflow fire. It is a combustion chamber. When the biomass are feed into the grate, the combustion start place, biomass will start combustion. After completing the combustion, the ash particles are get down to the downward direction or ash hopper, and the flames or combustible gas or flue gas are passed through the different types of heat exchanger. First one is the slack screen. First one, they making a slack screen by controlling the ash particles to the contact with the heat exchanger tubes, because in heat exchanger tubes, when the ash particles are contact with the heat exchanger tubes, it stick to the surface, making an insulator. By making insulator means it reduces the heat transfer to the flue gas to the heat exchanger tube. To avoid that these kind of problems, we make a slack screen in starting stage of after exit from the combustion chamber by collecting the impurities particles or filtering the impurity particles, ash particles. Next one is the secondary superheater and primary superheater. Last one is the generator plants. Secondary superheater means it has a higher temperature in the plant. Higher water temperature in the plant is the secondary superheater, and primary superheater previous stage to the secondary superheater. And the generator bank means in generator banks we water are converted into the steam. Lastly, flue gas passed through the chimney. It is another type of combustion system, solid fuel combustion system. Here we have a ternary superheater, secondary superheater, primary superheater, generator banks and backhoes, economizer. In this we have three types of superheater: primary, secondary and tertiary superheater. Generator banks are used to convert the water into the vapor. Water into vapor. Then vapor passes to the primary superheater. Here is further temperature slightly increase in the primary superheater. Then passes to the second stage of a superheater, the secondary superheater. In secondary superheater, further the temperature increases. In last stage is the ternary superheater. The temperature of the steam increases around 500 degrees Celsius or 650 degrees Celsius. Then it is passed to the steam turbine. By expanding the steam into the steam turbine start rotating. The steam turbine connects with the generator. Generator also start rotating. By rotating of a generator, we produce the electricity from the plant. The main focus of the large combustion system is producing electricity or consuming heat energy with electricity. Backhouse used for filtering the before sending to the flue gas to the atmosphere, we filter the dust particles, ash particles in the flue gas. After filtering, we send to the flue gas to the atmosphere. Next one is the history of combustion, theory of combustion, calorific value, high cross calorific value. Already we seen that when the fuel and oxygen combined and start combustion takes place, it produces the products and heat. How much amount of heat we can extract from this type of fuel? For different fuels we have a different calorific value or different heating value. It is a different types of fuels. Next is the types of firing. Biomass co-firing. Biomass co-firing means in some cases biomass have a low calorific value. In some cases biomass have a low calorific value. We combined with the different types of fuel. One is suppose biomass having low calorific value. We combined with the coal. It is a co-firing. We combine the two biomass or commercial fuels combined and we burn it. It is a single combustion chamber. It is a co-firing. Maybe indirect co-firing or parallel co-firing. Direct co-firing means we mixed with both the biomass fuels, biomass fuels and commercial fuels, and start burning in the combustion chamber. That is a direct co-firing. Indirect co-firing means it is combustion in the separate place. Biomass are combustion in the separate place and commercial fuels are combustion in the separate combustion chamber, and both the flue gas are heat the same area. It is indirect co-firing. Next, parallel co-firing. Parallel co-firing means both the fuels are parallelly combusted. And next is the incinerators. Incinerator means it is used for decomposing the or combustion of a municipal solid waste. Some material is suppose medical waste need a high temperature combustion because of a we need to kill the bacteria or microorganism or dangerous microorganism. Then we use for a high temperature incinerators. These are the incinerators used in the biochemical system.